going to talk about counting in section 10.6. And counting is not just like counting 1, 2, 3, 4, but it's the application of techniques for finding the number of objects in a collection. So we're just going to work through the examples 10.6a through 10.6b, and we're just going to learn how to find the number of objects in like word problem form. So first we're going to start with 10.6a, and it's a word problem, and it says a combination lock has a dial with 40 numbers 0 through 39. So it's important that you know that is 40 numbers. 0 through 39 is 40 numbers because you count 0 as a number. And it requires the user to remember 3 of those numbers in order. Assuming that numbers can be repeated, how many possible 3 number combinations can be created? And this is a very simple application. All you're going to do is you have 3 numbers like the problem says. So your first number, second number, and your third number. Okay, 3 numbers. Each number can be repeated. So there's 40 possibilities for your first number, 40 possibilities for your second number, and 40 possibilities for your third number. Now that is because 0 through 39 is 40 numbers. So each time there is 40 possibilities for each number. All you do to solve that is you just multiply all 3 of those together. 40 times 40 times 40 is 64,000 combinations. Okay, so there are 64 different ways and 64 different combinations you can get with 3 numbers having 40 numbers apiece, or can be 40 numbers each. So next we're going to look at example 10.6b, and it says different states have different requirements for their license plate. One state's basic format is to have 3 letters, so the first 3 the characters on the license plates are letters A to Z, and then followed by 3 digits. So it's 6 characters altogether. How many license plate can this state create using this format? Here it's easy to just go ahead and do like a little table chart. It's in your book on page 483. You can look at it. And so it just kind of sets it up like this. This is the space. There's going to be 6 characters all together, and it just labels it possibilities. So the first, I'm going to go ahead and label 1, 2, 3, 4, 5, and 6 because it's going to be 6 characters. And the first 3 are going to be letters. So there's 26 letters in the alphabet. So you're going to write the first space, there's 26 possibilities. The second space, there's also 26 possibilities because the first 3 here are letters, okay? And then here are numbers, right? All right, so in the third space, we're still on letters. There's 26 possibilities. And then on the fourth space, we get into our numbers 0 through 9, which is actually 10 numbers because you count 0, okay? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is 10 numbers. So there's 10 possibilities. Same for 5, same for 6. Now, to find the total amount of possibilities, you just multiply, just like we did up here, 40 times 40 times 40. You're just going to multiply these all together. 26 times 26 times 26 times 10 times 10, and your answer, 17,576,000 different license plates. Okay, and that's example 10.6b. The next thing that we're going to talk about is a permutation, and that is on page 483 as well. And I'm going to read to you what a permutation is because you're going to need to know how to tell the difference between a permutation and a combination. A permutation, we have a notation for it, and it has a big P here, and then right here is an N, and right here is an R, and we call this permutation notation. So permutation is a number of ways to select R individuals in a particular order out of a group size N, okay? So N is going to be your total group size. R is going to be a particular order. Now, a way that you can tell when to use a permutation is if it says something like first, second, or third place, or captain, co-captain, and something else. It has to be a particular order, and that's the way I remember that is the big P. We're doing a permutation, and it has to be a particular order, so it will say like gold, silver, bronze, first, second, third. When you get to your word problems, you'll see what I'm talking about, but right now, we're just going to look at how to solve permutations. So if you'll flip over on page 484, example 10.6c, we have an example of a permutation, and simply it just says to evaluate. But first we have to know the formula for a permutation, all right? And that is NPR equals N factorial over N minus R factorial. Now, I need to go ahead and explain to you what this factorial means. This means that if you have any integer, it could be 5, it could be 12, it doesn't matter, you would multiply every positive integer after that number all the way down to 1. So if I say 12 factorial, then to solve that, I have to say 12 times 11 times 10 times 9 all the way down into 1 and then evaluate it, okay, just by multiplication. So that's what we're doing here. I'll show you how to do it with the formula. I'll tell you how to do it on your phone, but your calculator also has a setting where you can just type in the numbers and it gives you an answer. Today we're going to learn how to do it with the formula, okay? So your example in your book is 20p8. And this is N, 20 is in the place of N and 8 is in the place of R, okay? So you're going to fill out this formula with 20 and 8. So N is 20, so 20 factorial over parentheses 20 minus 8 factorial. When you solve that on down, it's going to be 20 factorial over 12 factorial. Okay, now, like I said previously, factorial is, for 20, is 20 times 19, times 18, times 17, times 16. You have a button in your phone or on your calculator that you can just type in 20 factorial. If you turn your phone sideways, you'll have a little button that is an X with an exclamation point, okay? And you can type in 20 and hit that button, and then hit divided by 12 and hit that button, which is X factorial, okay? And it will give you the answer. If you don't want to use your calculator and you want to do it the hard way, then what you do is you would say, okay, 20 times 19 times 18 times 17 times 16 times 15 times 14 times 13 times 12. Now, technically, I would have to go all the way down to 1. But because this is 12 factorial, I can stop at 12 because everything after 12 is going to cancel out and be 1. So really, you can leave it like 12 factorial and then put it over top of 12 factorial because that's what this is. This cancels out and you would just have to multiply 20 times 19 times 18 times 17 times 16 times 15. When you do all of that, you get 5,079,110,400. Now, I do have to warn you, when you use your cell phone and you use this X button factorial, you have to push enter. So you would have to say 20, this button, divided by 12, this button, and hit equals, okay? If you don't hit equals, it's not gonna give you the right answer. So be careful on that. If you want to do it the long way, just make sure you can do it to where you do it all the way to 1 on both, but it's just not needed. Once you get to whatever this number is, everything just cancels out anyway, so you don't have to do that. If you have a TI 83 or 84, it should be the same. To find permutations in your phone or in your calculator, you hit your math button and go all the way over to the PRB button, and then you can go right down and find your factorial button, which is 4, or you can go ahead and use your permutation button, which is super easy. Just hit your math button, go over to probability, and you can use, you can play around with it and use your probability or permutation button right there.